Hello everyone, I am Jagdish Patel, Assistant Professor, Sandhi Foundation, Nasik. The name of subject is Broadband Communication System. This one is Unit 3, Multi-Channel System, Lecture number 2, in which we are going to see Modulation, Multiplexing and Demultiplexing. I am having 12 years of teaching experience, specialization in digital communication. Modulation, Multiplexing and Demultiplexing. Modulation and multiplexing are electronic techniques for transmitting information efficiently from one place to another. Modulation makes the information signal more compatible with the medium. Multiplexing allows more than one signal to be transmitted concurrently over a single medium. And demultiplexing allows one signal to transmit over more than one medium. Modulation and multiplexing. Baseband transmission. Baseband information can be sent directly and unmodified over the medium or can be used to modulate a carrier for transmission over the medium. In telephony or intercom system, the voice is placed on a wire and transmitted. In some computer network, the digital signals are applied directly to coaxial or textured pair cables for transmission. Broadband transmission. A carrier is a high frequency signal that is modulated by audio, video or data. A radio frequency RF waves is an electromagnetic signal that is able to travel long distance through space. A broadband transmission takes place when a carrier signal is modulated, amplified and sent to an antenna for transmission. The two most common methods for modulation are amplitude modulation and frequency modulation, AM and FM. Another method is called phase modulation, PM, in which the phase angle of the sine wave is varied. So here this one is a modulation at the transmitter end. Here we can observe the input in the form of voice or other intelligence can be given from a source side to an amplifier. Amplifier amplified the signal and given the baseband signal to the modulator. Modulator modulate the signal and the another input to the modulator is high frequency carrier oscillator. After modulation, the modulated carrier signal is given to power amplifier and power amplifier used to boost the signal and increase the strength of the signal before transmission to the another end, and from after that the signal is passed through an antenna. Here if you observe the types of modulation, that is amplitude and frequency modulation. Here in the diagram A side there is amplitude modulated wave, that is sinusoidal unmodulated carrier wave, sinusoidal modulated wave varying with respect to time. In the B diagram, if you observe the varying frequency sinusoidal carrier or modulated wave and sinusoidal modulated wave varying with respect to time. So these are the difference between amplitude modulation and frequency modulation. Baseband transmission, frequency shift keying FSK take place when data is converted to frequency varying tone. Device called modem, modulator and demodulator translate the data from digital to analog and back again. Demodulation or detection take place in the receiver when the signal baseband is extracted. Multiplexing. Multiplexing is the process of allowing two or more signals to share the same medium or channel. The three basic types of multiplexings are frequency division, time division and code division. Modulation and multiplexing. Multiple baseband intelligent signals are given to MUX, that is multiplexer. After that, the multiplexer signals are given to modulator, that is composite or multiplex signals. Modulator receives another signal from carrier oscillator, and the signal from modulator is given to RF power amplifier, and amplifier signal is given to antenna, and then the signal is transmitted. The electromagnetic spectrum, the range of electromagnetic signal encompassing all frequencies, is referred to as a electromagnetic spectrum. So this one is an electromagnetic spectrum in which the frequency bands are divided: extremely low frequency, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extremely high frequency. So these are the bands which are divided. Depends upon their applications, they can be used. Frequency and wavelength. A signal is allocated on the frequency spectrum according to its frequency and wavelength. Frequency is the number of cycles of the respective wave that occur in the given period of time. A cycle consists of two voltage, polarity reversal, current reversal, or electromagnetic field oscillator. Frequency is measured in cycles per second. The unit of frequency is Hertz, Hz. Wavelength is the distance occupied by one cycle of a wave and is usually expressed in meters. Wavelength is also the distance traveled by an electromagnetic wave during the time of one cycle. The wavelength of a signal is represented by a Greek letter lambda. Frequency and wavelength. One cycle is, this one is a frequency period, and one wavelength is nothing but from amplitude to amplitude it is been measured. Frequency range from 30 Hz to 300 GHz. The electromagnetic spectrum is divided into the segments: extremely low frequency, voice frequency, very low frequency, and medium frequency. And their frequency ranges for ELF 30 to 30 Hz, VF 30 to 3000 Hz, 300 to 3000 Hz, VLF include the higher end of the human hearing range up to about 20 kHz, low frequency 30 to 300 kHz, medium frequency 300 to 3000 kHz, high frequency 3 to 30 MHz, very high frequency 30 to 300 MHz, ultra high frequency 300 to 3000 MHz. And they can be used for different applications. The applications for TV channel, cellular phones, military communication, FM radio broadcasting, television channels, microwave and super high frequency SHF, satellite communication, radar, wireless LAN, microwave ones for 1 to 300 to 1 to 30 gigahertz, extremely high frequency 30 to 300 gigahertz, satellite communication, computer data, and radar. Bandwidth. It is that portion of the electromagnetic spectrum occupied by a signal. Channel bandwidth refers to the range of frequency required to transmit the desired information. More room at the top. Today, virtually the entire frequency spectrum between the approximately 30 kHz and 300 MHz have been spoken for. There is tremendous competition for these frequencies between companies, individuals, and government services in individual carriers, and between the different nations of the world. The electromagnetic spectrum is one of our most precious natural resources. Communication engineers is devoted to make the best use of that finite spectrum. Great efforts goes into are developing communication techniques that minimize the bandwidth required to transmit the given information and thus conserve spectrum space. These provide more room for additional communication channel and gives other services or uses an opportunity to take advantage of it. Spectrum management and standards. Spectrum management is provided by agencies set up by United States and other countries to control spectrum uses. Federal Communication System, Federal Communication Commission (FCC) and the National Telecommunication and Information Administrator (NTIA) are the two agencies that deals in spectrum management. Standards are specifications and guidelines necessary to ensure compatibility between the transmitter and the receiving equipment. Communication applications are simplex AM and FM broadcasting, digital radio, TV broadcasting, digital television, cable television, facsimile, wireless remote control, paging services, navigation and direction fading services, telemetry, radio astronomy, surveillance, music services, internet radio and video. A survey of communication applications, that is duplex, telephones, two-way radio, radar, sonar, amateur radio, citizen radio, family radio services, the internet, WAN, MAN and LAN. So these were the different parameters that is modulation, multiplexing, demultiplexing, bandwidth, wavelength, spectrum used for communication between the two devices, which make use of broadband services and optical services. Thank you.